They set out to build a machine that could never be surprised. A vehicle so advanced that failure would be designed out of it before the first prototype ever moved. Every weakness would be solved in advance, every future battlefield anticipated, every risk neutralized by intelligence and technology. The decision was framed as caution, but from the very beginning, it created a system that could not survive reality. At the height of Cold War confidence, money was abundant, urgency was unquestioned, and fear was a powerful motivator. The assumption was simple. The next war would be faster, deadlier, and more technologically complex than anything before it. Existing tanks were seen not as inadequate, but as dangerously obsolete. Incremental improvement felt irresponsible. If adversaries were leaping ahead, then standing still meant falling behind. The only acceptable response was a leap of equal or greater magnitude. Engineers, generals, and politicians aligned around a shared belief that complexity itself was safety. If a tank could do more, see more, calculate more, and adapt more, then it would dominate any battlefield it entered. Simplicity was equated with vulnerability. Redundancy, automation, and innovation were treated as moral imperatives rather than trade-offs. This decision felt unavoidable because it answered a fear no one wanted to name out loud, that the existing doctrine was aging faster than the hardware. A new generation of threats loomed in theory, simulations, and intelligence briefings. To counter an imagined future, the machine had to embody that future in advance. Waiting to see what actually happened was framed as reckless. So the question everyone obsessed over was how advanced the system needed to be. How much firepower? How much speed? How much automation? How many roles one platform could absorb? Meetings revolved around specifications, capabilities, and performance envelopes. If something could be added, it was debated. If it could not be added, it was reconsidered. What no one questioned was whether all of those advances had to exist in the same vehicle, at the same time, for the same mission. The internal logic was airtight. If the tank was going to fight the next war, it needed to defeat not just current enemies, but hypothetical ones. That meant longer engagement ranges, faster target acquisition, better survivability against unknown weapons, and seamless coordination with other units. Each requirement justified the next. More sensors required more processing power. More processing power required more cooling. More cooling required more space and weight allowances. Increased weight demanded a more powerful engine. A more powerful engine demanded a new transmission. A new transmission required custom integration. Each step made sense in isolation. Together they formed a closed loop that reinforced the original decision. The tank was no longer just a tank. It was a platform, a system of systems, a technological statement. Early progress appeared to validate everything. Prototypes existed. Tests were conducted. Demonstrations impressed visiting officials. On paper, the machine outperformed anything else in development. Simulations showed dominance. Controlled trials showed promise. Each success was quiet but reassuring. The program was working. That quiet success was dangerous because it occurred in an artificial environment. The system functioned when carefully maintained, when operated by specialists, when variables were limited. There were no muddy fields, no rushed repairs, no stressed crews, no supply shortages. The absence of friction made complexity look manageable. Every problem had a solution, usually involving another subsystem. There was a moment when reversal was still possible. Costs were rising, schedules were slipping, and integration challenges were becoming visible. Some voices suggested narrowing the scope, cutting features, or splitting roles across multiple vehicles. Technically, it could still be done, but psychologically, it was already impossible. Too many careers were tied to the vision. Too much prestige was invested. Admitting that the core assumption might be wrong felt like admitting that years of work, billions in funding, and international cooperation had been misguided. No one wanted to be responsible for killing the future, so the program locked in. Sunk costs stopped being warnings and became justifications. The more expensive it became, the more it had to succeed. Institutional momentum replaced critical evaluation. Problems were reframed as temporary. Delays were explained as growing pains. Complexity was no longer a risk. It was proof of ambition. Then the inversion began. The features that were supposed to guarantee dominance started to undermine the machine. Maintenance became a nightmare. Systems interfered with each other. Reliability dropped. Training requirements ballooned. The tank demanded conditions that real battlefields could not guarantee. Its strength required support structures that did not exist. Invisible costs accumulated. Not just money, but time, flexibility, and opportunity. Alternative designs were abandoned. Simpler upgrades were postponed or canceled. Entire generations of crews trained for a vehicle that never stabilized. Doctrine bent around a machine that never arrived in usable form. By the time the truth became unavoidable, the decision had already done its damage. The program was canceled after consuming unprecedented resources. It became the most expensive tank development effort in history, not because of corruption or incompetence, but because of one assumption that preventing failure required solving every possible problem in advance inside a single machine. The program was the MBT-70, a joint-use German main battle tank meant to redefine armored warfare. Its collapse was not caused by bad engineering, but by the belief that complexity was safety. The lesson is not that innovation is dangerous or that ambition should be punished. It is that systems fail when decisions are made to eliminate uncertainty rather than manage it. When fear drives design, complexity grows faster than understanding. And when a system cannot tolerate imperfection, it eventually collapses under the weight of its own certainty.